everyone, welcome to InsightsByRish. In today's video, I am going to implement a recommendation system which will recommend us some workouts. So here we will input the user data like what is the BMI index, what is the age, what is the gender, and depending upon all these attributes of an user, the system will recommend us the exercise along with some diet plans and the equipment that we require for those exercises. So this recommendation system will be based on content-based filtering method. So this content-based filtering method relies on the attributes of users to recommend items. It ensures that the recommendations align with the user's attributes or the specific characteristics of users. So this is an underlying theme of content-based filtering, and as you can see, this diagram represents here the content-based filtering technique. Like the figure 1, or we can say the image 1 or the person 1 represents the first user. Now this user performs some set of exercises as shown here. So the user 1 is performing some set of exercises and the user 2 is very similar to that user 1. So whenever the user 2 will enter the attributes, and the system will try to analyze that to whom this user 2's attributes are matching with. So when the system will find that the user 2's attributes are matching with this particular user 1, then those set of exercises which the user 1 is performing will also get recommended to that user 2. So this is how the content-based filtering method will work. Now the second part here is the basic components of this particular project. So on the user side, we will have the user input. So here we are manually taking the input from the user, and depending upon that, the recommendations will take place. Then we will display the recommendations to the user, and also we will collect the user feedback. Now here in the recommendation system, we have multiple evaluation metrics from which we are going to make use of MRR, which is mean reciprocal rank. And for this mean reciprocal rank, we require a feedback matrix. Now for this feedback matrix, we will be taking feedbacks from the user, and depending upon that feedback, we will compute the evaluation metric, that is MRR. So that is on the user side. Now coming to the core recommendation engine, here we will process the user input after taking it, that is we will clean it, we will perform encoding, normalization and all those stuff. Then to actually implement this content-based filtering, here we will make use of cosine similarity. This will help us to compute the similarity calculation. Thirdly, we will generate the recommendations, and at the last stage, we will collect the feedback. Now on the data part, we have a data set which is a CSV file, and on that data we will perform some pre-processing like cleaning, encoding, normalization, and at the last we will evaluate our recommendation model using the mean reciprocal rank. Now to understand more about the data set, this data set for the workout recommendation have been taken from this particular site, which is data.mendeley.com. So here I will provide the link of this site in the description box. You can download your dataset in the CSV format from this particular site. Now once you download this, it's actually in Excel format, but doesn't matter much. You can still utilize it in a CSV way. Now after downloading this dataset, I have loaded this dataset here in the Google Colab environment, as you can see. Now we will start performing the project here. The first thing that we are going to do here is data loading and cleaning. So let me just write it here. Data loading and cleaning. So here we will first load our dataset, which is an Excel file. So firstly, what we will do is we will import the necessary libraries here. So import libraries. First we require pandas here. So import pandas as PD. Then we also require numpy here. So import numpy as NP. Then the next libraries we will import as per the requirement whenever they are required, so that we can understand that at which point of time we require what libraries. So right now till this point of time, we just require this numpy and pandas. Let's run this cell. Now here I will say data is equal to PD dot. Now this is an Excel file, and hence I will make use of read_Excel method, and here I will paste the path of that Excel file. So let's run that for now. And let's see what all columns we have in this particular data frame. So let me just say here data.columns. So these are all the columns that are present right now in our data set. Now as you can see, there is a column that we don't require, and that is the ID column. So this is a column that we don't require for any kind of recommendation, and hence we will drop this particular column. So the first thing that we are doing in the cleaning stage is deleting unwanted columns. So here I will say data.drop columns is equal to, and here I will specify the name of column, which is ID, and then I will say in place is equal to true in order to make this changes permanent. So let's run that. Now let's view our data frame here. Let's see how this looks like. So I will just display the first 3 rows here. So this is the data set that we have. Here we have the gender of a person, age, height, weight, hypertension, and the hypertension is a categorical data, that is either yes or no. Then diabetes, again this is a categorical data. Then BMI level, again this is a categorical data. And then fitness goal, fitness type, exercises, equipment, diet and recommendation. Now what basically we are going to do is this from sex up till the fitness type. These are all the columns for which we are going to take the input from the user. It is depending upon the particular specific attributes of an individual user. They will input the data here, and depending upon the data that they have entered here, we will recommend them some exercises, equipment and diet. And let's also check the shape of this data. So data.shape. So this particular data set consists of 14 columns and 14,589 rows. Now the next thing that we are going to perform after performing this data loading and cleaning is label encoding. So let me just say here, second part is label encoding. Now as you can see, I already mentioned that this columns like hypertension, diabetes and level, they are categorical in nature, and it is necessary for us to convert these categorical values into numeric ones so that the model can analyze those values, and hence we are performing the label encoding here. So for this label encoding, we will require the label encoder module from scikit-learn, and let's import that first. So from sklearn.preprocessing, I will import label encoder. You can also make use of one hot encoder or get dummies method, but label encoder is an easiest one, and hence I'm using that. After that, here I will create a variable of label encoder. Let's say label underscore enc. This is, we can say, an instance of that module. Just a minute. And here I will load that module. So label encoder. After loading that module, we will actually convert the categorical data into numeric one using this label underscore enc instance. So here I will say for column n. Now here we have to specify the columns which are categorical in nature. If you see, even the gender column, even that column is in categorical nature. Hence the first column that we will input here is sex, second one being hypertension, third one being diabetes, fourth one being level, then the fitness goal, and then the last one being fitness type. Then inside this for loop, here I will say data column is equal to, here we will make use of this label underscore enc instance, and here I will make use of fit underscore transform method. This does both the work of fitting the model and then transforming it in one single go. And here I will pass again the data column. So whatever data that we are transforming from that particular column will get modified in that existing column itself. We aren't making any new data frame and then storing the transformed values in that new data frame. We are modifying the data from the existing data frame itself. So let's run that for now. Now let's see how our data frame looks like after performing label encoding. Let me just again say here data.head, and I will again display the first 3 rows here. So as you can see, now those categorical values are in numeric fashion, that is the value for gender. Now it is in 1-0 format. 1 means female, or I think 1 means male, actually 1 means male, and 0 means female. Then even have the hypertension here. For no it is 0, and for yes it is 1. Even for the level, if it is underweight it's 3, if it's normal it's 0, if it's overweight then it is 1, and if it is obese then it is 2, and so on. So we have successfully performed this label encoding. Now as you can see, these three columns, that is exercises, equipment and diet, though they are categorical in nature, still we haven't encoded them, and that is because we aren't using them in any input part. They will be used in the recommendation part. That is, these are the columns that we will recommend to the users. We aren't supplying these columns to our model, and hence it's fine that they are in the categorical nature. There is no need to convert them into the numeric one. The next part that we are going to perform here is normalization. So let me just say here, I think it's third. Yeah, it's third. And here I will say normalization. Now, right now you can see that all these values from all these columns that are numeric in nature, these values are on different scale. That is, for sex, it is just 0 or 1. Let me just demonstrate it to you here. Just a minute. So data.describe. So here you can see for the value, first value sex, the minimum value is 0 and the maximum value is 1. That is such a small scale, just between two consecutive numbers, 0 and 1. Secondly, for age, it is between 18 to 63. Now that's a larger scale as compared to the previous column. For height, again it's smaller, that is minimum is 1.3, maximum is 2.0. Now for weight, again the minimum is 32 and maximum is 130. Again this is a larger scale as compared to the height and sex column. So right now all these columns are on a different scale, and it's necessary for them to be on one single common scale, and hence we are performing this normalization. So let me just perform this normalization, and for this we first need to import the module from the scikit-learn. Now for normalization, you can either perform standard scaling or min-max scaling, but I will be going ahead with the standard scaling, which is an most effective and efficient method. So here I will say from sklearn.preprocessing, I will import standard scaler. Then I will again create an instance of the standard scaler. Let's name it as scaler, and here I will call this standard scaler. Now after that, again I have to fit and transform this data. So here I will say data, and here I have to specify the columns for which I want to perform this normalization. Now as you can see, for the categorical columns, that is for sex, hypertension, diabetes, level, fitness goal, they are label encoded. So we don't have to perform any kind of normalization for them. We just have to perform the normalization for the columns which are randomly on any scale, that is age, height, weight and all those. So let me specify those columns here. The first one being age, the second one being height, the third one being weight, the fourth one, I think it should be BMI. Apart from these 4 columns, all other columns are labelly encoded. So we will just perform normalization for this particular 4 columns. And here I will say scalar. I will make use of this instance. Then I will make use of fit_transform method. And here I will again pass this entire list of columns from the data frame. So let's run that for now. And now let's look how our data frame looks like. So let me just say data.head, and I will just display the first 3 rows here. So as you can see, now they are normalized. So right now they are on one single common scale, or we can say at least the difference between the minimum and maximum for all these columns is not drastically different. So this was the third part of normalization. So we performed data cleaning, then we performed encoding, then we performed normalization. Now we are moving ahead to the main core part of this project, which is recommendation model. So here we are going to write a function, and that single function will do 3 tasks. Firstly, it will also perform the task of recommendation. Secondly, it will also perform the task of collecting the feedback from the user. And lastly, it will also perform the task of evaluating based upon that feedback. So this single function will do all this work. So let me just say here, fourth part, and that is recommendation, feedback and evaluation. So let's write the function here. Let's name this function as get recommendation, and in this function let me just say top n is equal to 3. That is, maximum recommendations that we will give to an user will be 3. It can be less than 3, but it shouldn't exceed 3. So at some point, if the recommendations are coming to be very similar, then in that case we will give just the 2 recommendations. And if the recommendations are different in nature, then we will give all 3 recommendations. But the limit of recommendations shouldn't exceed than 3. Hence the top underscore n is equal to 3 has been specified here. This is a default argument. Next, let me just print it here. Please enter your details for a personalized workout and diet plan recommendation. Now, after printing the statement, here I will take the user input. So user input is equal to, now in this user input, as I said previously, we have to take everything that starts from the sex column up till the fitness type. So let me just take this user input. Here I will say first is sex column, that is the gender of a person, and that will be int. So we will be taking all these values in the integer format, or we can say in the numerical format. So int put, and here I will say enter sex. That is, if you are a male, enter 1, and if you are a female, then enter 0. Actually parenthesis and not curly bracket. Fine. So here we will take the gender from a person. If it is male, then it will be 1. If it is female, then it will be 0. The next input here will be age. Again, it will be in integer. So here I will say int input, and here I will say enter age. This was the second input. Now the third input here is height. Now this height is a float attribute. That is, this height that we are taking will be in meters, and hence it will be a float attribute. Hence I will say here float input, and here I will say enter height in meters. Let me also give an example here, that is example 1.75. So after taking the height from the user, the next thing that we are going to take is the weight of a person. So weight, and again the weight will be in float data type. Float put, here I will say the weight in kg. Now after this, the next thing that we are going to take is hypertension. So hypertension. Now this hypertension is again a categorical value, but we are taking it in numerical fashion. That is, if the person is having hypertension, he will enter 1, and if he don't have any hypertension, he will enter 0. So here I will make use of integer data type, and I will say input, do you have hypertension? So here, if the person has hypertension, that is yes, then he will enter 1, and if he doesn't have any, then he will enter 0. After taking this attribute as an input, the next thing that we are going to take is the diabetes. So diabetes, again that will be in integer format. So input, here I will say, do you have diabetes? Now here, if the person has diabetes, then he will enter 1, that is for yes it will be 1. Just a minute. And if a person doesn't have diabetes, then he will enter 0. After diabetes, the next thing that we are taking as an input is BMI level. So BMI is body mass index, and this BMI will be in float data type. So float put, and here I will say enter BMI. After this body mass index, the next thing that we are taking as an input here is level. That is, level basically means that you are underweight, you are normal, you are overweight, or you are obese. So here I will say level, and that will be in the integer format because those are encoded values. So either they will be 0, 1, 2 or 3. So input, and here I will say enter level. That is, if you are underweight, then you will enter 3. If you are normal, you will enter 0. If you are overweight, so if you are overweight, you will enter 2, and if you are obese, then you will enter 1. After taking this level, the next thing that we will be taking as an input here is the fitness goal. So fitness goal, again this will be in the integer format, so int input, and here I will say enter fitness goal. Now in this fitness goal, you just have two categories. Either you want to perform weight gain, so weight gain, and if the person want to perform weight gain, then he will enter 0, and if the person want to perform weight loss, then he will enter 1. So here we just have two categories, either weight gain or weight loss. Now after taking this, the last input that we want to take here is the fitness type. Again this will be in the integer format, so input, and here I will say enter fitness type. Now this fitness type, again it will be it will have two categories, either muscular fitness or cardio fitness. So if a person wants muscular fitness, then he will enter 1, he or she will enter 1 basically, and if the person wants cardio fitness, then the person will enter 0. So these are all the inputs that we are taking from the user. After taking this input, again we have to normalize this. So as you know, for the original data frame as well, for model training, we have normalized the data, and even after taking the input from the user, we need to normalize those inputs. So here I will just say normalize the inputs. So here I will say num features, that is the numerical features, is equal to, here I will specify the columns that needs to be normalized, and those are same as that of the normalization that we performed for the original data set, is age, height, weight and BMI. So let me just copy it from here and I will paste it here. So we have to normalize only the values from this 4 columns, because the remaining columns are label encoded. Then here I will say user df is equal to pd.dataframe. In this data frame, I will pass the user input, that is this user input I will pass in this data frame function, that because right now this user input isn't in a data frame format, but for performing the normalization or encoding or any kind of task further, we need that data to be in the data frame format, and hence we are converting it into the data frame format. And then here I will say columns is equal to, the column names will be equal to that of numeric features here. Let me just put it here. After creating this user data frame, we will perform the transformation, or we can say the normalization, on this particular user data frame. So let me just say here user data frame, numeric features. Whatever transformations we are doing, that is whatever normalization that we are performing, we will be storing the transformed values in the existing user data frame itself. We won't be creating any new data frame to store the new values or transformed values. So here I will say scalar. This scalar is an instance of standard scalar that we have already loaded and used for the existing data frame. And then here I will make use of transform method, and in this I will again pass this numeric features from user data frame. After that we will say here user input, and here I will say dot update. Now here I will say user data frame at location, or we can say at index 0 to dictionary, and again I will convert this into the user data frame. So user data frame is equal to pd dot data frame, and here I will pass this user input. Now after normalizing this inputs, the next thing that we are going to do here is to calculate the similarity scores. Now as I already mentioned in the beginning of this video, that is this calculation of similarity scores, we are going to perform it using the cosine similarity. Now what this cosine similarity does is, basically I won't be going into much deeper theoretical part, I will just give you a glimpse here. And this cosine similarity is basically used to measure how similar two vectors are. So whatever feedback vectors we will be getting here, those will be compared with each other, and depending upon that we will compute the similarity. Now, once this cosine similarity scores are calculated, that is between the new user's profile and existing user, the new user profile will be created after inputting or after getting the data from the user, and that vector will be compared with an existing user's vector. And when the similarity will be found, or when the cosine similarity score will be computed, then the system identifies the top similar users, that is those with the highest similarity scores. So from the entire existing data that we are training, as you can see, this is an data frame that we are training our model upon. So from this entire data frame, with whoever the new user's vector will be similar to, that person's recommendation will be given to this new user as well. Let's say we are inputting the data for a new user A, and if that user A's data, or we can say attributes, are similar to that of user from this particular data set, let's say at index 1, this particular index 1 has the attributes very similar to that of the new user's input. So whatever recommendations we have here for this particular user will be also given to that user A. So this is how the cosine similarity will work. And then the system generates recommendations based on the most common exercises and diets of the similar users. So this is how we are making use of cosine similarity here. So let's do that. Here let me just say calculate similarity scores. Now first we have to specify the user features here. The user features, and the user features, as you already know from the data frame, that is the data. Let me just specify the names of columns. Now as you already know from the existing data frame data, we won't be making use of this exercises, equipment, diet and recommendation columns here while model building stage. We will only make use of the columns from sex up till fitness type, because the remaining columns will be given as a recommendation here. So we will specify the names of all these columns here. Let me just start with it. First one is sex. The second one here is age. The third one is height. The next one here is weight. Then hypertension. After hypertension, it is diabetes. Then BMI. Then level. Then fitness goal. And the last one is fitness type. So these are all the columns that we will be extracting from the existing data frame data. And then here I will say similarity scores. I will compute the similarity scores here between, let me just call this cosine similarity. Now for that we first have to import the cosine similarity module from scikit-learn, and let's do that. So let me just say here itself from sklearn dot metrics dot pairwise quote cosine similarity. Let's run that for now. Now here we will make use of this cosine similarity module. Let me just copy it from here and I will paste it here. Now between what we are computing this similarity? Between this user features and the user data frame. This user features are the features of existing users from the data frame, and this user data frame is the attributes of new user, and between them we are computing our similarity scores using cosine similarity. And then we will flatten this data here. So let me just say here flatten. So we are done with computing the similarity scores here. The next thing that we are going to do is we are going to retrieve top similar users and get their recommendations here. So let me just say here retrieve top similar users and get the first recommendation. Now what do I mean by the first recommendation? See, the first recommendation is that whenever the new user will input its attributes, those attributes will be compared with the existing users from the data frame, and with whoever the similarity score will match, or with whomever the similarity scores will be high for that new user, that particular user's recommendation will also be given to that new user. Next, for the second and for the third recommendation, what we are going to do is we are going to shift the values of attributes for the new user slightly, either in the positive side or in the negative side. And then again we are going to compare, or we are going to compute the similarity between the shifted attributes of the new user with the existing users from the data frame, and again give the recommendations based upon that. So for the first recommendation, it will be exact match, and for the second and third recommendation, it will be a slightly changed, or we can say a slightly modified match. So here I will say similar user indices. So here I will call this similarity scores method, and here I will make use of arg sort method. So argument sort, and here I will just say from -5 up till end, and then -1. So here we have performed basic slicing, nothing else. So we are getting the similarity scores, and then we are sorting it for the top 5. And after sorting it for the top 5, the next thing that we are going to do here I will say similar users. So similar users is equal to data dot location, that is the location of index, that is I location, and then I will just pass the similar user indices here. So wherever we are getting this highest similarity scores, that scores will pass to the data, and depending upon that, that particular index, that particular location will be extracted. So our recommendation 1 here, just say here recommendation 1 is the first recommendation, which will be an exact match to the personality of that new user. So here I will just say similar users, and from similar users, whatever recommendation columns I want to specify, or I want to demonstrate, that I have to specify here. Let's say from this existing data frame, I just want to recommend the user with the exercises and with the diet. Then I will specify just these 2 columns here in this particular list. If I want to recommend a person exercises, equipment and diet, all these 3 columns, then I will specify all these 3 columns here, and hence I will do that here. Let me just say here exercises. After exercises, the next column will be diet. I will be recommending the person a diet, and then I will recommend the equipment. Then here I will say mode, and then I location 0, that is the topmost. So we will compare the attributes of the user with those of existing from the data frame, and wherever we will find the similarity scores, we will take the topmost row where the similarity is highest, and that user's recommendation will also be given to this new user. Now what we are going to do here is we are going to give the remaining 2 recommendations here. The first recommendation here has already been given. Now we have to give the remaining 2 recommendations. Let me just say simulate recommendations, actually 2 additional recommendations, by modifying the user input slightly. So here what we are going to do, as I already said, let me just first create an empty list. So let the name of list be simulated recommendations. Then we will write the for loop for this. So let me just say here for underscore in range 2. It is maximum, it will give 2 recommendations, and if the remaining 2 recommendations are getting same, then only a single recommendation will be given. So here let me just say modified input. We are modifying the user input here. So modified input is equal to, first we will just create a copy of user input here. We won't be making any changes, permanent changes in the existing user input. We will just copy that user input here in the modified input variable, and then we will make the changes in this particular modified input variable. Then let me just say here randomly adjusting age, weight and BMI with larger variations. So let's say if a person has entered his age as 25, the weight as 60, so we will make slight variations in that, and we are making that variations randomly. So either they can be in the positive side, or either they can be in the negative side. Let's consider the positive side. So the 25 will become around 27, 26, and if it is in the negative side, it will become 24, 23 and something like that. So then it will trace the nearby users to the user's attribute. and depending upon that, again the recommendations will be given. So here we will just say modified input, and we are modifying the age here, plus equal to, because it can be either in the positive side or in the negative side, and random. First we have to import this random module. Let me just import that here. Let's run that for now. Now here we will make use of that random module, and here I will say random module dot random integer, and the variations will be anywhere between -5 to +5. That is, either there will be an addition of +5 or there will be a deduction of -5. So if considering the age 25, either it will become 30 or it will become 20. Then secondly, let me just copy this thing. Now here we will change this age to weight, and we will change this to BMI. Now for BMI, we will just shift the values from -1 to 1, because BMI values are highly sensitive and they do not exceed a certain range, and that's something related to your health, and hence there shouldn't be any large variation in that value. Hence for BMI there will be just a shift of +1 or -1, but for age and weight there will be a shift of +5 or -5. Now after modifying these inputs, the next thing that we are going to do is, again we have to normalize this modified inputs here. So let me just say here normalize modified inputs. So here I will say modified user data frame is equal to, again we will create a data frame out of this. So data frame, I will pass this modified input here, and then the columns will be equal to that of numeric feature. After doing that, here I will call this data frame, and that is modified user data frame. Now from this data frame, I will normalize the numeric features. Let me just paste this here, is equal to, again I will make use of that scalar instance, then I will transform the data, and here in the transform method I will again pass this modified user data frame and the numeric features, basically the numeric columns from that modified user data frame. And then here I will say modified put dot update. We are updating this modified user data frame here, dot iLocation 0 to dictionary. So now we have also normalized our modified input values. After doing that, the next thing that we want to do is to calculate similarity scores for this modified inputs. So let me just say that calculating similarity scores for modified input. Now here what we will do, as you know, we have already computed the similarity scores for the original user input. The next thing that we want to do is, now that we have shifted the values of the original user input, again have to compute the similarity scores between the existing data from the data frame and between this shifted values. So let's do that now. Here I will say modified similarity scores is equal to, again I will make use of cosine similarity here. So let me just say here cosine similarity, and in this I will pass this user features. This user feature consists of all the input columns from the existing data frame data, and then we are comparing it with the modified user input. So let me just say here pd.dataframe, and here we are converting this modified input after updating again into the data frame format. So let me just put it here. And after doing this, I will flatten this entire data. Flatten. Now after doing that, again we will take the topmost similarity scores here. So again I will say modified similarity user indices is equal to, we will take this modified similarity scores from here, and again we will make use of arc sort method here. So arc sort, then we will take top 5, and here I will say -1. Fine. Now after doing that, again here I will say modified similarity users is equal to data dot I location, that is the location of an index, and then I will paste this modified similarity user indices variable here. So basically here what we are doing is, whenever we are computing the similarity score between the shifted values of the user input and existing data from the data frame, then we are seeing with which particular row the similarity scores are the highest, and with whichever rows the similarity score is highest, that particular row index we are, or we can say the location of that row we are extracting here. And after doing that, again we are going to say here recommendation is equal to modified similar users. Actually modified similarity users, actually instead of similarity users I will just make it similar. So similar, we just change this here itself, and here in the recommendation as well I will make use of this modified similar users variable. Now again I have to specify the columns that I have to recommend to the user. So the first one is exercise, diet and equipment, all these three columns. Let me just paste it here, and then again I will say here mode and I location 0. That is the topmost recommendation from that 5 rows. This recommendation 1 will be the exact match, and the remaining 2 recommendations or the remaining 1 recommendation would be a slightly different match. Now after doing this, what we have to do is we have to check if the recommendation already exists or not. Let's say in this we are giving 2 new recommendations. So second recommendation has already been given. Now while giving third recommendation, if this new third recommendation is already given, that is if it is exactly similar to that of the second recommendation, then we won't give it, because we don't want to give similar recommendations again and again. Why to give repetitive recommendations? So it's better to not give duplicate recommendations here, and hence we will check if the recommendations are already given. If they aren't given, only then we will give that. So here let me just say check, and we are doing all this stuff inside this for loop itself. Fine. So check if the recommendation is already in simulated recommendation. So here I will say if not any recommendation sizes equal to recommendation exercises and REC, that is the short form for recommendation, diet equal to recommendation again diet, and if not that equipment is already recommended, equipment for REC in simulated recommendations. So if the recommendation for any diet, equipment or exercise, if it doesn't exist in the simulated recommendations, only then we will give it. If it already exists, then we won't give it. So here I will say simulated recommendations dot append the recommendation. So here we are handling the duplicate recommendations. After doing that, we will come out of this for loop here. So let me just come out of this for loop, and here I will display the recommendation for the first one. That is the first recommendation, which is the exact match with the user's personality. So let me just say here print. Here I will say recommended workout and diet plans based on your input. Now here I will just say print in new line recommendation 1. Now as you know, this recommendation 1 is the exact match, so let me just say here exact match. So here first I will print the exercises, just say here exercises, and here I will say recommendation 1 exercises. Similarly, we will repeat this stuff for the remaining two attributes as well, and that is equipment and diet. Let me just write this in uppercase. Second one here is equipments, and the third one here is diet. So equipment and diet. So this was for the first recommendation. Similarly, we have to display the recommendations for the remaining two parts as well. That is either the two recommendations or one recommendation. For index IDX or recommendation in enumerate simulated recommendations, start is equal to 2. So here I will again print recommendation at index IDX, and here I will say slight variation. That is, if this is a second recommendation, it will be displayed second, and if it is third recommendation, it will be displayed as third. Here I will print again the same thing, print exercises, and from here I will say recommendation, from here exercises. And we will also repeat this for the remaining two attributes, and that is equipments and diet. Let me just copy it from here and I will paste it here. I just have to change this to recommendation short form, that is REC. Everything else will remain same. So here we are displaying the recommendations. First recommendation, which will be the exact match to the user's personality, and the remaining two recommendations or the remaining one recommendation. If there is no repetitions, the remaining two recommendations will be shown. If there is any repetition in the recommendation, then only a single recommendation will be shown. After showing these recommendations, to evaluate this recommendation model, we also have to collect the feedback for each recommendation, and that is what we are going to do it here. Again, we will come out of this for loop, and inside this function itself, we'll just say here collect feedback for each recommendation. So here I will again create a feedback matrix. So feedback matrix is equal to, right now it will be an empty list. So here I will again write the for loop. So for I in range length of simulated recommendations. So whatever the length of simulated recommendations is, plus 1. And here I will say feedback is equal to int, because feedback will be an integer value, and here I will just say was recommendation I plus 1 relevant. So let's say after showing the recommendation, it will show the placeholder to take the feedback from the user, and it will ask, was the first recommendation useful, or are you satisfied with that? Then you have to enter 1 if you are satisfied, or if that recommendation was relevant to you, and you have to enter 0 for no. So let me just say it here, question mark, and here I will say if you are satisfied with that recommendation. Let's say that recommendation is relevant to you, you will enter 1, and if it is not relevant to you, you will enter 0, and it will repeat for n number of times, and this n will be equal to the number of recommendations you have in your simulated recommendations. And then here I will just say feedback matrix dot append. I will append this feedback. Now after taking the feedback from the user, we have to calculate the MRR, which is mean reciprocal rank. So let me just say here calculate MRR is mean reciprocal rank. Now here I will just say here relevant indices is equal to I plus 1 for I comma feedback in enumerate feedback matrix. So we are just taking the relevant indices here. If feedback is equal to 1. After taking this relevant indices from the feedback matrix, here I will just say if relevant indices, then mean reciprocal rank, that is MRR, is equal to numpy, that is NP, that is an alias to numpy dot mean, and we will take the mean of that. So 1 divided by rank for rank in relevant indices. The relevant indices means we are just taking the feedback where the value is 1, that is the user has found that particular recommendation as relevant, and then we are dividing 1 with that relevant indices, whatever the rank of that relevant indices is, and that is how we will calculate the MRR if, let's say, the indices are not relevant. If the user haven't found the recommendations as relevant, then we will say here else MRR is equal to 0.0, which means there is no relevant recommendations for that particular user. Again, this entire thing that we are performing is in this particular function itself. We haven't came out of the function yet. Now in this function itself, here I will say print mean reciprocal rank, this MRR, which is an evaluation metric for our recommendation model, and here I will say MRR dot 2f. Only for the first two decimals it will be shown. After doing that, here I will return the simulated recommendations. So return first the recommendation 1, that will be the exact match, and then the simulated recommendations. Now we will come out of that function. So now we are coming out of this function, and here we will call that function and get the recommendations. So let me just say here get recommendation or get the recommendation. So here I will just say recommendations is equal to, I will call this function which is get recommendation. Let me copy it from here and I will paste it here, and here I will again specify top underscore n is equal to 3, that is top 3 recommendations. Let's run that for now. So as you can see, after running this, now it is taking input from us. First we have to enter the gender. Let's say the user that has came for the personalized workout plan is a female. So let's enter 0 and let the age of that female be 21. Let the height be something, let's say 1.63 in meters, of course. Let the weight be somewhere around 60. Let's say the person has hypertension, or let's say that female has the hypertension problem. So we will enter yes, and as the person or the candidate is young, we will say that the person or the candidate doesn't have any diabetes, so 0. Then let's enter the BMI. Let's say randomly the BMI is 16. Now let's enter the level. Let's say the person is normal, neither she is underweight nor she is overweight, so 0. And fitness goal, that is whether that female candidate wants to gain weight or wants to lose the weight. So let's say the person wants to lose the weight, so 1. Now the fitness type, whether she wants to perform muscular fitness or cardio fitness. Let's say muscular fitness. So as you can see, we are getting a personalized workout plan recommended here, and you can see we are getting just the 2 recommendations. This is because there might be a third recommendation which will be exactly similar to that of recommendation 2, and as we are not giving repetitive recommendations here, that third recommendation have been omitted. As you can see, this is the recommendation 1 which is the exact match, and the recommendation 2 which is slightly variated. Now you might see that the exercise remains same, just the equipment and the diet plan changes. Now here we have to give the feedback whether we found this as useful or not. So let's say we found the first recommendation to be useful, and hence for the first recommendation I will enter yes. Now it will ask us for the second recommendation. Let's say that the candidate didn't found the second recommendation to be useful. So let's enter 0. So as you can see, these are our recommendations, and the MRR, or we can say the mean reciprocal rank, is 1. Let's say if the candidate would have entered recommendation 1 as 0, that is, the person wouldn't have found the recommendation 1 as relevant, and if she would have found the recommendation 2 as relevant, then in that case the mean reciprocal rank would have been 0.75. And let's say if the person wouldn't have found any recommendation useful, then the mean reciprocal rank would have been 0. And let's say if the person would have found both the recommendations useful, then the mean reciprocal rank would have been 0.5, that is 50-50. So this is how you build a recommendation system for personalized workout and diet plans using the content-based filtering technique. Now I will provide this GitHub repository in the description box. Do check that. On that I have the dataset and also I have the code file here. You can go through this code file and try to implement the same project here. So do check the description box to get this GitHub repository. So that's it for the video. Thanks for watching.